Hello, we are HSU's Portable Mobility Assistance Team. My name is Marissa Riviera, and my teammates are Miles Heskett, Amelia Fedor, Joe Lawson, and David Muma. The HSU's enterprise mission is to make advancements in health research, safety, and outreach, which has led us to partner up with Little Brothers Friends of the Elderly, also known as LBFE. LBFE is a nonprofit volunteer-based organization that reaches out to the elderly in the community who need medical assistance and more. But for our project, we specifically focused on their medical transportation service.
LBFE serves elders in the Keweenaw and offers medical transport services within the local community, Ishpeming, and Marquette. Elderly individuals tend to struggle with maneuvering into car seats and moving their legs inside the car as they lack upper body strength. Currently, LBFE volunteers assist elders physically. This poses risks to the elderly and volunteers. LBFE is seeking a solution that has a low impact on the elderly and is affordable.
These requirements led to our problem statement: create an affordable, safe, and low-impact solution to help strength and mobility restricted elders enter and exit vehicles with limited volunteer assistance, so that the volunteer can help transport the elderly person.
The objectives for this design are fairly straightforward. The design must be easy to use, safe, low cost, and have all-weather construction. Along with ease of use comes ease of repair in the case of any type of failure, as well as a simple design that is intuitive and requires little to no training. While discussing the problem with LBFE, we created the following design constraints. Each piece of design must weigh less than 20 pounds to ensure the volunteers can lift and maneuver the device. Design must also be simple to use so that volunteers won't need extensive training in order to operate the device. There can be no modifications to the vehicle that the device will be used with, as volunteers' vehicles may be different. Finally, the device must support a user of 180 pounds at maximum and must be easily transportable in a small vehicle.
While conducting market research, we came across a commercial device. The slide and ride shown here is used to transfer users into the car. However, the users are required to maneuver themselves using their arms to slide along the board to enter and exit the vehicle. This is a specific challenge that LBFE wanted to address. In addition, from reading customer reviews, we noted several downsides to this device. Chief among these were the cost at $700 per unit, poor stability, and that each order is vehicle specific and cannot be used on other vehicles. There are two risk and safety factors that the team had to consider. The first was our own safety during the manufacturing process. Improper tool usage and unsafe working environments were our risk factors. To mitigate these, the team adhered to strict shop rules and always wore PPE items while in the shop space. To ensure the work environment was safe every time the team used it, we would do a preliminary check to ensure all spaces were clear of potential dangers and unnecessary debris. The second risk factor the team had to consider was the user's risk, with improper use being the user's risk factor. To prevent this, the team decided to create a user manual to describe the proper function of the device. This manual will be delivered to LBFE along with the final design.
When selecting parts for our final design, we kept our engineering constraints in mind, along with the takeaways from our first prototype. Chiefly, plywood was replaced with HDPE sheet since it was affordable, easy to work with, and light. Our final design, which we named the Auto Slide, is an improvement over our previous prototype. Improved materials and machining have made it more compact, easier to use, and perform its function more smoothly compared to the prototype. You can see the Auto Slide in action here on the screen. Our final design testing included the same testing regimen as our prototype, with the exclusion of drop testing. This is because we are delivering this final design to our customer. Testing followed this regimen. Fitment tests were conducted in several vehicles, such as a Chevy Equinox, Jeep Cherokee, and GMC Sierra. This was to ensure that the device fit well within the vehicle without obstructing anything. Then, a load test was conducted where the device was incrementally loaded up to 1.5 times its maximum capacity. This was to ensure the design's structural integrity. Then a comfort test was conducted where teammates would sit on the device in a vehicle and note any discomforts. Then we moved to dynamic testing, which included rapid acceleration and braking from 30 miles per hour, sharp turns, and rapid acceleration to 45 miles an hour. This was done in 3 stages. First was a load test where 270 pounds was strapped to the top of the device. Next was a mannequin stability test, and finally an occupant test. Video was taken by securing a camera to the mannequin and occupant. Additionally, other teammates other than the driver noted any abnormalities. Finally, destructive testing was conducted on the prototype to determine the durability of the design. This was done from heights of 3 feet and 5 feet per 10 cycles.
Regarding our material choice, we decided on components and materials based on our requirements and objectives. The material must be strong enough for the needed task, but also must be lightweight, accessible, and affordable. Testing was conducted using the regimen discussed beforehand. Success at each test was required before moving to the next. This ensured that testing was done methodically and in a safe manner. Testing was done with a safety for users mindset and attempted to anticipate potential problems or hazards. Safety was used as our most important indicator. This project came about hoping to solve a safety problem. Thus, if our solution introduced any hazards, it would be deemed a failure. Destructive testing was conducted on our prototype to predict lifetime and potential breakpoints in the design. This helped inform parts of our user manual. Here are our standards.
And these are our deliverables for the end of the semester, and we would like to acknowledge the following people, our references, and thank you so much for watching.